Okay gang, so for part B, the first thing I did is factor the numerator and denominator, that's here. And then I found the domain of the denominator, so I set the denominator equal to 0, and I got -2 and 3. So then for the x-intercepts, I set the numerator equal to 0, so I got 2 and -3 for that. And because the exponents on each of those, on each of those factored forms is a 1, that's why I got that they're both odd. So remember, for an x-intercept, odd means that it's going to go through the x-axis. It goes through the x-axis. Okay, for the y-intercepts, I then let all the x's equal to 0. So you can see that I did that here. I got -6 over -12, which reduces to 1/2 for the y-intercept. Then I went back for my vertical asymptotes. Vertical asymptotes come from the denominator. It's where the denominator is equal to 0, but the numerator is not equal to 0. If the numerator and the denominator are both equal to 0, that's actually a hole in the graph and not a vertical asymptote. So you want a non-zero over a 0 when you do this. So when the denominator is equal to 0 at -2 and 3, that is where my vertical asymptotes will occur. Since they're both first degree on the exponents of both of this factored form is a 1, they're both odd, which means that they're going to go in opposite directions, meaning one is going north on one side of the vertical asymptote and the other is going south, okay, opposite directions. Then for the horizontal asymptote, you have to look at the degree. So the degree of the numerator is quadratic, or 2. The degree of the denominator is also quadratic, or 2. So remember, if it's equal in degree, it's the ratio of the leading coefficients. I'll say that one more time. When you're finding the horizontal asymptote, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the ratio of the leading coefficients. So in this case, it's 1/2. And then if you're trying to find if the function crosses the horizontal asymptote, you actually have to set the function equal to HA and see if it's solvable. If it's not solvable, then it doesn't. If it solves out to a particular value, then that's where it crosses, and it only crosses at that value, or if you found 2 values, at those 2 values, but it only crosses there and will not cross anywhere else. So I set this equal, I did it in this form. I set it equal to 1/2. It was a question mark, which is the HA, and I'm trying to see if this is solvable. So I had already cross-multiplied this up. So you can see here I had already cross-multiplied this up. I then multiplied the 2 through. I had an x squared on both sides, so we can get rid of that. The -6 on both sides, get rid of that, which left me with 2x equals 0, which means that you only cross when x is 0, which made sense because that's the y-intercept, and the y-intercept happens to be at the same exact height that HA is. So that made sense that that would be the only point that would be allowed to touch the HA. All right, so then what I did was I put up the points I had. So I had the x-intercept of 2 and -3, and I put up the y-intercept of 1/2. And I put up, okay, so where you started to figure this out was right here, because you knew these, oh, let me say that a little clearer. You then put up your vertical asymptotes, and the vertical asymptotes we said were going to be at -2 and 3. So I put up -2 and 3, I put up my VAs, I put up my HA at 1/2, and I put up all my intercepts. Okay, once I did that, I could see that these two were going to connect. We already know that this is going to cross, so we could see that this was going to go up. It's not going to go back down because there's no x-intercepts here to cross through. An x-intercept would be like a doorway you could cross through. There's no doors, so you can't get cross through here. So this is stuck doing this, and again, if you're not sure, you can always plot extra points. Now we said that the vertical asymptote was odd, so if on this side I'm going north, on the other side I must be going south. Just don't cross the horizontal asymptote. So this is going to stay in here like this. Likewise, on the other one, this VA, we know this one's also odd, so this guy's going south, which means on the other side it has to be going north, and then it'll just wrap around the horizontal asymptotes. Okay gang, I hope you enjoyed the video. That's it on this one. I'll catch you. Bye-bye.